So you shouldn't probably watch every second of this video. You should try the practice test by yourself before you jump into watching this video. Check your answers. Any answer that you didn't get right, I couldn't figure out, jump to that part of the video. But if you did a problem without any hitches, then there's no need to watch this part of the video. Try to speed this up for yourself. The first problem is just asking me to do some work with my functions that are provided to me. Part A wants me to set the f function equal to 0 and solve for x. Just going to do two steps. I'm going to subtract 15 and divide by -3. My answer is just going to be x equal to some number. So I subtracted 15 and got -3x equals to -15. Then I'll divide both sides by -3. And my answer to part A of number 1 is just going to be x equal to 5. Part B has an inequality, and if I have to divide by a negative to isolate the x, I flip the inequality. Adding and subtracting doesn't flip an inequality. Dividing by a positive doesn't flip an inequality. But I set this up so you need to flip the inequality. So for part B, I'm going to set the f function -3x plus 15. I'm going to set it greater than 0. I'm going to do the algebra to solve for x. Same algebra, -15 divided by -3. And when I divide by a negative, that's when I have to flip the inequality. If I add or subtract, that doesn't flip an inequality. When I divide by a positive, that doesn't flip an inequality. But dividing by a negative is what I'm doing right here. That causes me to flip an inequality. In terms of an answer, I'm isolating the x on the left side when I divide by -3. I'm changing the greater than to less than, and -15 divided by -3 is +5. If you would have solved this backwards from me and got the x on the right-hand side, that's fine. Your algebra will look different. Your answer will look different. But the important thing is, if you write the answer with the x on the opposite side, that the opened end of the inequality should be pointing towards the 5, the pointy end pointing towards the x. These are both correct answers. Similarly, I could have, for problem part A of number 1, wrote the answer 5 equals to x as well. But that's probably more common. C wants me to set the f function equal to the g function, or set the right side of the f function equal to the g function. I'll do -3x plus 15 equals 7x plus 5. Do the algebra to isolate the x. Specifically, I'm going to -7x and -15 from both sides. On the left side, the x's have the same sign, so when I combine them, I'll add and keep the sign negative and get -10x. Canceled out the 15's on the left side. On the right-hand side, I canceled out the 7x's. On the left-hand side, 5 minus 15 is -10. I'm going to finish this problem up by dividing both sides by -10. On the left-hand side, I'm left with an x. On the right-hand side, negative divided by negative is a positive. 10 divided by 10 is 1, so I get just plain ordinary 1. Part D, I'm going to put the f function's right-hand side less than the g function's right-hand side, and do exactly the same algebra, meaning -7x minus 15 and divide by 10. It's the same problem structurally. The symbol is the only difference in it. So -7x minus 15 -7x minus 15. On the left-hand side, the numbers in front of the x's are both negative. I'll add them and keep them negative. I canceled the 15's. I don't change the inequality when I'm adding or subtracting to isolate. On the right-hand side, I cancel the 7x's. 5 minus 15 is still -10. If I was dividing by a positive, I wouldn't change the direction of the sign. But here I'm dividing by a negative, so I need to change the direction of my sign. And when I change the direction, I'm going to get x is greater than 1 for an answer. And the equivalent good answer would be to be 1 is less than x. Pointy part of the inequality pointing towards the 1, open part towards the x. 2 is an equilibrium problem. I won't get into the theory, I'll just do the problems. 2 gives me a supply equation where P is the price in dollars of some product, S is the number of units of that product will be supplied. It gives me a demand equation where P is the price of that product and D is how many units will be demanded at that price. Question A wants me to find out how many units will be supplied at a price of 3. Because it tells me to use the supply equation, I'm going to take my supply equation and plug 3 in for the price. So the supply, when the price is $3, is going to be 6 times 3 minus 5, which is 18 minus 5. At $3, there's going to be 13 units available, made available for sale by the who's ever supplying this. How many units will be demanded at a price of $3? Same computation, but using the demand equation. The demand, when the price is $3, is negative 4 times 3 plus 15. That's going to be negative 12 plus 15. And that's just going to be 3. So suppliers are more excited than the purchasers. At a price of $3, they'd make 13 units available for selling, but the buyers would only want 3 units. So for part C, at a price of $3, does supply exceed demand or demand exceed supply? Supply is 13 units, demand is 3 units. The supply exceeds the demand. There's more product available at that price than consumers want to buy. D, find the equilibrium price. That's just setting the supply equation equal to the demand equation and solving for P. Again, these are not realistic functions at all. We're just trying to make the numbers easy to work with. For this equation, I'm going to solve for P by adding 4P and adding 5 to both sides. When I do this, I get 10P equals 20. I'll divide by 10, divide by 10, and then the equilibrium price is going to be $2. How many units will be supplied at the equilibrium price? That's like saying how many units will be supplied at a price of $2. That's just plugging 2 into the supply equation because it's calling out supply. It's calling out the equilibrium price of $2. And the number of units that will be supplied is 7 units. Because this is equilibrium, I don't really even need to do the computation here. How many units will be demanded at the equilibrium price? Equilibrium price is the price where supply equals demand. To make sure my answer is right, I could take the demand equation, plug the equilibrium price of $2 into it, and get negative 8 plus 15, which is 7 units. Three gives me the revenue and cost functions, ask me to do various things with those functions. So 3, a company makes a single product. The monthly cost C to make X units of that product can be found by using the cost equation. The monthly revenue from selling X units of that product can be found using the revenue equation. Part A, find the cost of making 50 units. It's telling me I'm using the cost function. It's telling me that X is 50. The cost of making 50 units is 3, and then 50 in for the X, times 50 plus 500. That's going to be 150 plus 500. The cost of making 50 units is $650. What's the revenue from selling 50 units? I'm going to use the revenue function because it calls out revenue. I'm going to plug 50 in for X because X is the number of units and it gives me the same 50 units. The revenue from selling 50 units is going to be 8 times 50. And that's going to be a revenue of $400. Then it says, is there a profit or a loss when 50 units are produced and sold in a month? Well, if it costs $650 and I'm getting $400 in revenue, my costs exceed my revenue, there's going to be a loss. And there's two ways to write the loss. I can write it as a negative with the word profit, or I can just write it as a positive with a loss. So two ways to do this, but usually I would do this. The amount of revenue minus the cost. If it's positive, you're making money. If it's negative, you're losing money. There's going to be a $250 loss or a negative $250 profit. They mean the same. So without a sign, I can say there's a $250 loss if 50 units are made and sold, or I can say the profit is negative $250. A negative profit is a loss. Both of these would be acceptable. I suppose if you put a negative with a loss, I'd probably scribble out the negative but not take points off. Part E wants me to find the break-even quantity. For break-even quantity, you just set the revenue function equal to the cost function and do the algebra to solve for x. That's going to be the number of units that it would take to break even. So I'm going to subtract 3x from both sides and get 5x equals 500 and divide by 5, and that gives me 100 units is the break-even quantity. Ask me what's the cost at the break-even quantity of 100 units. To find the cost at any number of units, I just take the cost function, change the x to the number. In this case, the break-even quantity is 100. The break-even cost is $800. The revenue when you're selling 800 units, I can get by plugging in 100 for x, and that's what's asked me to find here, the monthly revenue at the break-even quantity of 100. The revenue is going to be R of 100, which is 8 times 100, and at a production level and sales level of 100 units, the break-even, the amount of revenue you get is $800. And what is the monthly profit? Well, break-even means you don't make any money. You don't make money, you don't lose money. If you take the revenue minus the cost, the revenue of $800 minus the cost of $800, you get a $0 in profit. That's what breaking even is. You're not making money, you're not losing money. Your profit is 0. I didn't quite write that so well. It should be $0 or $0 profit might be better. I'm kind of stumbling through writing this, but hopefully you get the idea. I'm going to need to pull out my calculator to do linear regression, and I'm not doing any graphing. I'm not even going to look at the graphs on my calculator. I'm just going to do the regression. So part 4 gives me some data that is probably mostly linear. I'm going to enter the data on my calculator and find a linear regression line. So turn my calculators on, clear, get back to the main screen, hit my stat button, hit the enter key, clear out anything I have in list 2, go by scrolling to the top of list 2 and hitting enter, clear out anything I have in list 1 by scrolling to the top of list 1 and hitting enter. Do that for both of my calculators. They work a little bit differently. And then in the list 1s, enter the x's of 1, 2, 3, 4, and 5 for both calculators. I'm just doing it on both calculators because they work a little bit differently. So my x's are in list 1. In list 2, I'm going to put the numbers 24, 14, 10, 4, and negative 2. So 24, 14, 10, 4, and negative 2. Have my data in. Now I want to find the linear regression line. I don't really have to graph this because I'm not asking you to graph it. But I will put it in, I'll just be consistent with what I'm done, but I'm doing more than you really have to do here. So now to get my equation, I hit my stat button, I arrow over to calc, and arrow down to linear regression. On my old calculator, I now hit second and 1 for L1, comma, and then second and 2 for L2, comma. This part's really not necessary. Vars, y-vars, function, y1, because I'm not actually sketching a graph. I'm not asking for that. You don't really have to do that part. You can get off skipping that part. Similarly, on this calculator, x is list 1, y is list 2. I can skip star regression in y1, or I can put it on there. It's not necessary. To get y1 right there, I go vars, y-vars, function equals. On this calculator, when I have it set up like this, I scroll down to calculate and hit enter. On this calculator, I just hit enter. They both give me the same equation, negative 6.2 for the number in front of the x, which is kind of a slope, plus 28.6. So let me just write my answer. The equation is y equals to negative 6.2x plus 28.6. What is the value of r? We should have our calculator set up for r. I'm going to round to 2 decimals and say r is negative 0.99. My calculator doesn't put the 0 before the decimal on my old calculator. Look how my new calculator does. That's probably preferred, the 0 before the decimal, rather than the way my old calculator did it. So everything about the new calculator is just slightly better, slightly more in line with what's normal. How strong is the relationship? I don't know if I have that sheet around here. Remember, if the r is greater, if the r absolute value wise is greater than 0.8, it's a very strong relationship. Should have had that sheet handy, but you can dig it out of section, is this section 4.3, I believe. Now use the equation to predict the y value that corresponds to 10. I'm just going to plug 10 in for that x. I'm going to go y equals negative 6.2 times 10 plus 28.6. And my answer is going to be y equal to some number. Doesn't matter which calculator I use. So negative 6.2 times 10 plus 28.6 gives me y equals negative 33.4. For this r, even though it's negative, I have to think of it absolute value-wise to determine how good the relationship is. And the absolute value of negative 0.9 is positive 0.99, and that's bigger than 0.8 by a lot. So it's a very strong relationship. Another linear regression problem where I'm not asking for a graph. I asked you to do all the graphs for homework on your calculator, and I didn't ask you to do anything other than look at the graphs, and so I'm not even going to look at the graphs to save some time. So I have some data here. It shows the gas mileage in miles per gallon and the weight of certain cars in pounds. So the x's I'm going to put in list 1, which are weights in miles per gallon. The gas mileages I'm going to put in list 2. I'm going to come up with an equation, and I might say something like, I don't know, the gas mileage equals some number times the weight plus some other number that I get from using my linear regression, rather than doing y equals mx plus b. I might try to make my numbers more useful in terms of the problem, but it doesn't really matter. Let's get this data in here and get our equations. So stat, but hit enter on edit, hit enter on edit, up and clear the data, up and clear the data, up to the top of the list, hit clear, then enter, up to the top of the list, hit clear, then enter. In my x's, I'm putting the weights, 2,200 pounds, 4,400 pounds, 3,200 pounds, 4,700 pounds. 2,300 pounds, 4,100 pounds. Bounce over to the Y's and do 33 miles per gallon, 19 miles per gallon, 26 miles per gallon, 17 miles per gallon, 37 miles per gallon, 22 miles per gallon. Now I want to get the regression line by hitting the Stat button, arrowing over to Calc, going down to Linear Regression, arrowing over to Calc and get down to Linear Regression. On this old calculator, all the stuff that I was doing with the L1, L2, and Y1, if you're not graphing it, you don't even need that. You can just hit enter and it'll give you the equation. On this calculator, if I don't want to store it in Y1, I could just go down to Calculate and hit enter. And I've got something going on. My equations aren't matching, which means my data isn't the same. Let me see what I messed up on. So stat, enter. Oh, look at that right there. That's 2,200. 2,200, 33, 4,419, 2,233, 4,419, 3,226, 4,717, 23. Boom, boom, boom. That looks okay. And now 2,200. That one's wrong too. 4,400, 3,200, 4,700. I think they're both right now. So let me go Stat, Calc, Linear Regression, Stat, Calc, Linear Regression, and this one I can just bounce down to Calculate if I'm not storing it or graphing it. This one I could just hit enter, and now they still don't match. Oh my gosh. Why? I made this, 4,400, sorry, 19. I don't know what the heck I'm doing. Oh, come on. 4,400, 3,200. This is what's happening. I'm just being an idiot. 19. I think that's going to be right now. Stat, Calc. So if you make a mistake like this on your test, I have to live with it. I will, not take many points off if I see an equation that I can tell you just messed up. So for my equation, I can write y equals, rounding to 2 decimals, this 0.007 is going to be negative 0.01. It's negative 0.01, should I say, in front of the x. And then plus 50.67 for the B. And again, I could say gas mileage G equals negative 0.01 times the weight plus 50.67. If I want to do something that's more descriptive, it's not necessary. Both of these give me an R rounded to 2 decimals of negative 0.98. Absolute value-wise, that's greater than 0.8, so this is a very strong relationship. And now I'm going to use either equation to predict the gas mileage of a car that's 3,000 pounds. I'm going to plug 3,000 in for whatever variable I represent for weight. I'm going to say the gas mileage is negative 0.01 times 3,000 plus 50.67, and doesn't matter which calculator I use, so negative 0.01 times 3,000 plus 50.67, and it gives me 20.67 miles per gallon. This is rounded to the nearest integer, so I'm going to round that up to 21 miles per gallon because my calculator gave me 20.67. And I'm going to round that up to 21. And that feels good enough. Let me stop here and do a part 2, just because I think this is maybe a little bit over halfway, and I'll make the videos kind of closer to equal in length.